Hey, welcome back. This is section 6.4, and in this section we're going to talk about the temperature and volume relationship of gases, which is Charles' law. In Charles' law, the Kelvin temperature, very important, is directly related to volume. Okay, and again, this time we're going to keep pressure and number of moles constant. When the temperature of a gas increases, its volume also increases. Okay, so if I light a fire under this piston right here, it's going, once those molecules start bouncing around faster, it's going to increase that volume because they're pushing harder on the walls. And so the relationship of Charles' law is drawn like this: V1 over T1 equals V2 over T2. So again, we have to have the P and the N constant if we're just looking at V and T. So V1 over T1 equals V2 over T2. If we solve for V2, okay, we're going to multiply both sides by, we're going to multiply both sides by T1, right? Because we're getting rid of T1. Sorry, T1. So we end up with V2 equals V1 times T2 over T1. Alright, and that's just basic math. We are multiplying to get V2 by itself, so that's why we also have to divide by T1. So that's how we rearrange to get V2. Now, can you solve for T2? T2 is on the bottom, so how are we going to solve for that? The way I do it is I flip them over. As long as I do the same thing on both sides of the equal sign, if you'll recall from algebra, that this right here is the same as T1 over V1 equals T2 over V2. And then I just solve for T2, so T2 equals T1 V2 over V1. The way the book does it is showing you here is they cross multiply first, okay? So they multiply T2 times that and V1 times that. And so then they solve for T2 that way and then bring that over and divide by that. Okay? So either way, look at them both and see which way makes more sense to you. Alright, so our first problem is that you have 785 milliliters at 21 degrees C, and you're going to drop the temperature to 0 degrees C. So what are we solving for? The new volume, okay? So we're going to have T1 equals 21. Got to add the 273 because remember, when you're using the temperature like this, it's got to be in Kelvin. V1 was, they told us, 785 milliliters. We are finding V2, and so the new temperature is 0 degrees C, so plus 273 equals 273 Kelvin. And so you rearrange to solve for V2, and then you just plug in your numbers, making sure that the K's are canceling so you're left with the right units, which in this case is milliliters. Alright, so here's a problem for you to work. So put me on hold and then come back and we'll work it together. Okay. Sample of gas has a volume of 420 milliliters. Alright, so V1 equals 420 milliliters. At a temperature of 18 degrees C, so that's 18 degrees C plus 273, equals, I think it's 294, but I am going to check. 291. See, 291 K. Alright, so I have another volume, which will be V2. It's going to equal 640 milliliters. And so they're saying, what temperature would I have to put that at to solve for that? Okay, so remember, we got to rearrange this formula. We know it's V1 over T1 equals V2 over T2, or like I said before, T1 over V1 equals T2 over V2. And so we're solving for T2. So T1 times V2 divided by V1 equals T2. And then it's just a matter of putting them in. And that's why I always do all my conversions over here. Okay, so I'll have equals T1, which was 291, okay, times 420 milliliters divided by V. Now what did I almost do? That should be V2, right? Not V1. So that's going to be 640. That's one of the most common mistakes you'll see. Okay, it's because we're dividing by V1. So you got to be very careful that you're putting in the right things. Okay, all right, and then you're going to say 291 times 640 divided by 420, and I'm getting 443 what? So that's the answer, right? No, that's Kelvin, right? Watch your units. So in order for me to give it, because it wants it in degrees C, I have to say 443 minus 273, which will give me 170 degrees C. So you could have missed that problem very easily. It's several steps, so you've got to be very, very careful when you're working these problems, as you know in chemistry already. All right, and then so they're going to show us how they worked it, and they also got 170. Okay, so just some conceptual things that you should go through. Pressure does what as volume decreases? Pressure increase or decrease as volume decreases? When temperature decreases, what happens to volume? Pressure does what when the volume changes from 12 to 24 liters? So how much does it change? Does it decrease or increase by what factor? And then the same thing with this question. So work on these, okay? So let's see how you did. Okay, when pressure increases when volume decreases. Temperature decreases as volume decreases. Pressure decreases when volume changes from 12 to 24 because it decreased. And we could even say how much it would, by what factor. And then volume increases as you increase the temperature. So just get all of those relationships in your head, because we're pushing through to the end of this, and we're going to get to the end and we're going to combine them all together. Oh no! Alright, so that's it for 6-4. I'll see you in a little while and we'll do 6-5 together.